All right, today we're stepping right into the machine shop. We're going to break down a real powerhouse of precision engineering, the conventional milling machine. We've taken some raw lab notes and we're turning them into a simple step-by-step guide so you can see how to take a chunk of metal and turn it into a finished part. Let's get right into it. So this is it, the conventional milling machine. This beast takes a rough piece of metal and just carves it up with incredible accuracy. But the real question is how? What are the exact steps you need to take to go from that raw stock to a perfectly finished part? Well, that's what we're here for. We're going to walk you through the whole process. So here's our game plan for today. We'll start by getting to know the machine and its tools. Then we'll cover the absolutely non-negotiable safety rules. After that, we'll walk through the entire process, from setting up to making that final cut. And to wrap it all up, we'll finish with a simple checklist to make sure it all sticks. Okay, first things first, let's get properly acquainted with the machine itself. Understanding its core components is really the key to operating it well and, of course, safely. Think of this machine as a whole system working together. You've got the head up top, which can be angled for all sorts of versatile cuts. The spindle, that's the heart of the operation. It holds and spins the cutting tool. Your workpiece sits on the bed, which moves side to side and front to back. The whole bed is held up by the knee, and that's how you adjust your height. And for this job, we're using a V-block to hold our round part nice and secure. All right, you can't exactly make a cut without the right tools, right? So let's move on and see what we'll be using to shape this metal. For this operation, our go-to tools are the cutters, of course, end mills, and a face mill, which is perfect for creating those super flat surfaces. For precision, we're gonna rely on vernier calipers for all our measuring. And this might surprise you. A simple hammer is one of the most important tools here. It's how we make sure our workpiece is locked down tight and isn't going anywhere. Okay, stop. Before we even think about turning this machine on, we have to talk about safety. This is, without a doubt, the single most important part of the entire process. You've got to respect the machine, and that starts right here. So I've got a question for you. What's the most important part of any job in a machine shop? Is it the precision? The speed? Nope. It's walking away at the end of the day with all your fingers attached. It's safety. Every single time. These rules need to become second nature, like breathing. Know where your on and off buttons are without even looking. Keep your hands on the wheels when it's running. That's your control. And always, always use slow, smooth movements. And here's a huge tip. Watch the chips coming off the metal. If they start turning blue or brown, that means things are getting way too hot. That's the machine's way of screaming at you to back off on your speed or the depth of your cut, immediately. With safety front and center in our minds, we can finally move on to the setup. And just like with any craft, proper preparation is what separates a pretty good result from a great one. So what's our actual goal for this task? It's simple. We're going to perform what's called a facing operation. That just means we're going to remove exactly 2 millimeters of material from each side of our cylindrical part to create 2 perfectly flat, parallel faces. Now, to hit that 2 millimeter target with absolute precision, you have to understand this term, least count. It's just the smallest, tiniest little increment the machine can measure and move. For our vertical z-axis, the least count is 0.1 millimeters. That means every single little mark on that dial represents a movement of just 1/10 of a millimeter. That's how we get this so accurate. Okay, step 1. Any dirt or little metal chips in the V-holder can throw your whole setup off, so clean it out until it's spotless. Then place your workpiece in there and clamp it down. And don't be shy. Give it a few firm taps with a hammer on the end. You need to be sure it's absolutely solid and won't shift even a tiny bit during the cut. This next step is so critical. It's called taking a reference. You turn the spindle on and then very carefully bring the spinning tool over until it just kisses the edge of the workpiece. The moment you see a tiny spark or hear that little touch, that's your 0 point. That's your starting line. Immediately back the tool away and turn the machine off. You've now established your starting position for everything else. All right, the machine is prepped, the workpiece is secure, and our reference is set. It's time to make some chips fly. Let's walk through the first cut step by step. But before we do, let's quickly define depth of cut, or DOC. This is simply how deep the tool is going to bite into the material on a single pass. We control this very precisely using the machine's handles and those vernier scales. For this job, we're going to be taking really shallow cuts. So now we put it all together.
First, set the Z-axis dial, that's your vertical control, to 0. This calibrates it to that reference point we just took. Next, turn that same handle to move the dial to the 1 mark, and since our least count is 0.1 millimeters, this sets our first depth of cut to just that, 1/10 of a millimeter. Finally, you just position the tool along the X-axis so it's ready to cut the first quarter of the workpiece's face.
And here we go. Turn the machine on. Using the Y-axis wheel, you're going to make a slow, smooth clockwise rotation. This moves the bed and feeds the workpiece into the cutter. You just keep this motion going until the tool has passed completely over that first section. Then you just rotate the wheel the other way, anti-clockwise, to bring it all the way back to the start.
One pass down. Now you just use the X-axis handle to shift the workpiece over so the cutter lines up with the next quarter of the face. Then you just repeat the process. Move the Y-axis in, then back out. You're going to do this for all 4 sections until that entire surface has a clean, beautiful machined finish. Then, and only then, do you turn the machine off.
So we've only taken off 0.1 millimeters. To get to our 2 millimeter goal, we just repeat. You raise the knee by turning the Z-axis handle to the 2 mark for another 0.1 millimeter cut, and you do all the passes all over again. You'll keep doing this, advancing the dial each time until you've done it 20 times. That's your 2 millimeters. Then you unclamp the part, flip it over, lock it down again, and do the entire process from scratch on the other side. Patience is key.
Whew, that was a lot of steps, I know. So let's just boil it all down into a super simple checklist that covers the most critical points of the whole operation. If you remember anything from today, remember this. Start clean. Lock it down tight. Always, always take a reference to establish your 0 point. Set that Z-axis dial to 0 before you dial in your first cut. And, most importantly, always turn the machine completely off before you make any big adjustments or unclamp your part. Safety and precision, they really go hand in hand.
And that's the process, from a raw cylinder to a precisely machined part. It's a fundamental skill, and it really opens the door to creating almost anything you can imagine. So now that you've seen how it's done, I gotta ask, what's the first thing you would make?